The next thing that we're going to do is use the name to write the formula. Now when we do that, the method we're going to learn only applies for ionic compounds. So you need to be able to recognize when it's an ionic compound and when it's a covalent compound. Ionic compounds contain either a metal and a nonmetal or a polyatomic ion. So the easiest thing to do is just look at the first word. If the first word is a metal or if it's ammonium. Remember, that's the only positive polyatomic ion that we need to worry about. So if it's a metal or ammonium, then it is an ionic compound, and we're going to follow the steps that I'm about to show you. All ionic compounds are neutral, so the charges of the cation and the anion must add up to 0. You can figure out the charges by looking at the groups on the periodic table or at the list of polyatomic ions. If there is something that could have multiple charges, then you're going to look at the Roman numeral. If you have more than one of a polyatomic ion, multiple of a polyatomic ion, we're going to use parentheses, not in the name, but in the formula. Okay, this is only in the formula. Right, so we're going to use parentheses if we have more than one of a polyatomic ion, and I'll show you what that means when we do some examples. Alright, so example 1, calcium chloride. Okay, this is our name, calcium chloride. We're trying to write a formula. So we're going to look first at calcium. What is calcium's formula? Ca. Chloride, what is that referring to? Well, that's just chlorine, right? And we changed the ending. So now we got to figure out how to write it so that the charges are neutral. Well, calcium is always a +2 charge because it's in group 2 on the periodic table. And then chlorine or chloride is always a 1 negative or a -1 because it's in group 17 or what they call 7A on the periodic table. All right, so here's our ions, calcium and chloride, and there's their charges. We've got to write it so that it is neutral. So let's look at how they show us to do that. If you'll write it with your charges up here, calcium +2, -1, and then use what is called the crisscross method. So this 1, just the absolute value from chlorine, comes down here, and the 2 from calcium goes down there. Then that will give us the proper formula, calcium Cl2, CaCl2 for calcium chloride. Now, why do we need 2 chlorides? Those 2 chlorides are each -1, and -1 times 2 is -2, and then calcium is +2, so that is how we get it to be neutral. We need 2 -1s to neutralize that +2. Okay, but you can just take your absolute value of your charges and crisscross, and that will balance them. Right, now, if your charges are the same, like you have +2 and -2, you do not crisscross. All right, those are already balanced. And we'll see some examples of those as well. All right, here's another example, iron 3 sulfate. Okay, iron is Fe. Now, Fe can have multiple charges, but it says 3. Now, that doesn't mean there's a little 3 down here. No, 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 no. +3 for your charge. Sulfate. Sulfate. That's not just sulfur. I got to look at my polyatomic ion sheet. That's SO4 with a -2 charge. All right, so I got +3, -2. I got to get these to balance. So I'm going to bring this 3 down. I'm going to need 3 sulfates and bring that 2 over there. I'm going to need 2 irons. Now, why does that work? Because 3 times 2 is 6, and -2 times 3 is -6, so that gives me charges that neutralize or add up to 0. So that's going to give me Fe. I'm going to need 2 of those, and SO4. That's sulfate. You can't change that 4 right there. So this is where I have more than 1 sulfate. I actually need 3 sulfates to balance with my irons. So this is an example of using those parentheses. Notice that you don't write the charges in the final formula. Okay, once you put the compound together, you don't write your charges. But you're going to write your charges when you're trying to figure out the formula. Right? There's a somewhat neater example of what I just showed you. All right, so let's do some examples here. Aluminum hydrogen sulfate. Right, aluminum has a +3 charge. Hydrogen sulfate, from my polyatomic ion sheet, has a -1 charge. Right, so I got to write these so that the charge is balanced. So I'm bringing the 3 down here and the 1 down here. Now when you write this, you're obviously not going to write the 1. So it's going to be AlHSO4 from a hydrogen sulfate. Now I need 3 of those, 3 hydrogen sulfates. So I got to put that in parentheses. I need 3 of them, 3 of the whole thing. The reason I don't just put the 3 right there is because I don't need 3 oxygens. I need 3 of that whole group to balance with the aluminum. Okay, so there would be my formula. Iron 2 oxide, Fe, and then here it says it's a 2 charge. It can have lots of charges, but it's a 2 in this one. And then oxide is just oxygen, and it has a -2. Now this is a good example of when the charges are already balanced. +2 and -2 add up to 0. So there's really nothing I need to do here. Just rewrite it FeO. Okay, that's iron 2 oxide. Now it's a little bit different when I get into iron 3 oxide. Fe, this is iron 3. So it has a +3 charge. And then oxygen has a -2 charge. Going to crisscross because these are not balanced. So that 3 comes down there and the 2 comes down here. Now I do not need parentheses because I don't have any polyatomic ions. I just have iron and oxygen. So Fe2O3. Okay, iron 3 oxide. All right. Let me erase these so I have room for the next few. Strontium carbonate, or excuse me, strontium chromate. So Sr for strontium. Strontium's in group 2, so it's always +2. Chromate is CrO4 with a -2 charge. All right, look how those are already balanced. So I don't really have to do anything except put them together. Now I cannot get rid of this 4 right here, or it wouldn't be chromate anymore. So SrCrO4. Potassium chloride. Potassium is K, and it has a +1. And chloride is Cl with a -1. So +1, -1, those are already balanced. So much easier when that happens. You can just write those together. Ammonium nitrate. Ammonium is a polyatomic ion, NH4, and it has a + charge. Nitrate, NO3, a polyatomic ion, has a -1 charge. Look, already balanced. So again, all I have to do is write them together. I don't know if I can fit it on here. NH4, tiny, N, think skinny, O3. Okay, again, you can't get rid of the 4 on the hydrogen or the 3 on the oxygen because those go with the name. NH4 is ammonium, NO3 is nitrate. Okay, so be careful with that. And then finally, lithium sulfite. So lithium has a +1. Sulfite is SO3 with a -2 charge. So I have a 1 and a 2. That's the S. That 2 is going to come down there. And I'm going to show the 1 going over here, but really we wouldn't write the 1. Okay, so when we write those together, that's Li2SO3. Again, you got to keep the 3 on the oxygen for sulfite. And then I've got the 2. I don't need a parentheses because I only have 1 of my polyatomic ion and then 2 of the lithiums. Right, so again, here's that answer written a little more clearly. All right, pause, rewind, ask questions as needed. When you've got that, I want you to go and do 2 and 3 on the worksheet.